page. Okay, if I click on link, how much time the page is getting loaded. So the load testing will test the load of the application. Okay, it will test the load of the application. Just 1 minute, I'm getting one call. Just 1 minute. Okay, sorry, sorry. Okay, fine. So load testing means it will test the speed of the application. So functional testing means it will test the functionality of the application, whether the application is working fine or not. In load testing, they will not concern about whether your application is working fine or not. They will only concern about the speed of the application. Okay. Okay. So you want just brief on regression testing? Huh? Okay. So regression testing, I'll tell you. See, very simple regression testing. See, regression testing is also a type of functional testing. Okay, it is also a type of functional testing. But what will happen in? I'll tell you the difference between functional testing and regression testing. So in functional testing, okay, in functional testing, so this will be done as a part of new application. That means first time I develop the application, and then before making that application to live to users, to move to production. So we do the functional testing. Okay. So regression testing means, suppose we do some enhancements actually. Okay. Already the application is in production, it is live, but some new features have come to that application. Some new functionalities have come to the application. So then what development will do? Development team will take that as an enhancements. Okay. Development team will take as enhancements actually, like changes. So then regression testing means, so they will test actually the changes that are done to the application so that the original functionality of the application should not break actually. Okay. So functional testing means this will be done as a part of new application and all the functionalities tested actually. All the functionalities tested. So regression testing means this will be done, okay, for the changes incorporated to the application to check that the changes, to check that the new changes did not impacted the functionality of the application. Functionality of the application. That means, suppose I introduced some new changes in the code, okay, as a part of the enhancements, So the new changes should not break your original functionality. Okay, should not break your original functionality. Otherwise, your entire application will be going actually because of the new functionality that you introduced. So that's why regression testing will check that. Okay, so these are part of the testing team, that activities. Then what is unit testing actually? What is unit testing? I told unit testing is implemented with developer who has written the code actually, right? Okay. Functional testing, regression testing, load testing, they'll test at the application level. Suppose my application is developed. Is it developed with 20 Java files? Okay. Unit testing will test, okay, will test at the Java file and method level. Okay. That means, in other words, we can tell that we need to test each and every piece of code. In the Java program or in the programming. Okay, this is so because unit testing is applicable not only for Java, even for other languages also. if you write the same program in .NET or C#.NET or Python, there also you will be writing unit testing. So we need to test each and every piece of the code in the program. So this is called unit testing. Okay, that means testing at the code level, testing at the method level, that is called unit testing. If you take functional testing, these are testing at an application level. Once the application is moved to dev environment, okay, or QA environment, okay, development server or QA server, then we will test that application. But unit testing will be tested at the program level itself, at the program level, at the code level. So that is why this is done by developers, not by testing team. So since the developers have written that program, so they'll test that whether that method is working properly or not. Whether that, suppose in a simple way, for example, I will write one class A. Okay. In that I'll have a one method. I pass one variable and I return one variable. This is a method, simple method. Some logic is there. Okay. Some logic is there. Okay. Now I know this logic because I have written this logic. Okay. I know what this logic does. I know. So based on that logic only, I know that. I mean, based on this requirement, I know this requirement. If I pass, say, X value as 10 to method one, then the return value or the output that the method one is returning should be 20. I'm just telling. So based on that only, I have written the logic. If I pass 10 to the X value, okay, this logic gets executed and the return value from this method will be 20. Okay, so I know what this logic is doing. Now I have to test this method whether this is working fine or not. I have to test this method, okay, whether this is working fine or not. So that is what we call it as unit testing. So we need to test each and every piece of code in the program. Okay, so like testing at method level, okay, whether that method is working fine or not. So like that is called unit testing. Okay, so basically we'll have like this. These are the steps. So in unit testing, okay, so we take like this. Unit testing, say we need to test a method is working, a method in a Java file is working fine or not. So what we do is, first step, okay, first step is take input to be passed to method. Next, okay, define the expected output from the method for the given input. Third one, execute the method by passing the given input. Okay. Next, then, okay, after execution, after method execution, output is written, and this is called actual output. Okay, if actual output and expected output are matching or equal, then the method is working properly. Otherwise there is an issue in the logic implemented in the method. So this is what actually, okay, this is what we do in unit testing. So in unit testing, we need to test a method in a Java file if it is working fine or not. Okay, if it's working fine or not, if we need to test a method in Java file, if it is working fine or not. So take input to be passed, take input to be passed to the, okay, method that needs to be tested. Then define the expected output from the method for the given input. Execute the method by passing the given input. After the method execution, output is written, and then this is called actual output. If the actual output and expected output are equal, then the method is working properly. Otherwise, there is an issue in the logic implemented in the method. Okay, so that means we make this as failed actually. If the method is working properly, means we make this as passed. That means test is passed. Otherwise, test is failed. Okay. Now, okay, these are the just read this. Very simple. Just read this. So take the input to be passed for the method that needs to be tested. Define the expected output from the method for the given input. Okay, because I know the logic, so I can predict that yes, based on this logic, this method should return that value. So that's why I define expected output. But I might be wrong. Okay, so that's why we are doing this testing. So execute the method. Now we'll execute that method by passing that unit. Now, after the method gets executed, output is written, and that is the actual output. That is the actual output of the method. So if the actual output and expected output are equal, then the method is working properly. We say test is passed. Otherwise, there is an issue in the logic implemented in the method. That is, we make this test is failed. Okay. See, let us take these steps very in an example. You will understand. Okay. Let me define like this. So I have a method like this, for example. I have a method like this. Int x, int x, int y. This is the method. Okay. Let me take this class sum. I call it as sum. Very simple. Okay, I'll go with an example sum. And then I just say int z is equal to x plus y. Okay. Then I just this add method returns an integer value. This takes two input values and returns one output value. Now I'll say return z. What this add method does? This add method is taking two integer values, adding the two numbers, and returning that sum. Okay, returning that sum. Okay, so just note down these points. Okay, this is very important actually. Now I'll be explaining according to these points. Okay, I'll be explaining according to these points. Now we need to do unit testing. Now we call unit testing. Now onwards we call it as unit testing. It is not functional testing. It is unit testing. That means testing each and every piece of the code. Okay, testing this method. Okay, we need to do unit testing of add method. Okay, fine. We know what method we need to test. First that is important. Without knowing which method you need to test, you cannot write the unit test. First, you should know which method you need to test. Okay, I am testing add method. This is what we do. We need to do unit testing of add method. Okay, now first, take input to be passed to the method that needs to be tested. First step. Okay, so what I do is input I define like this. Input x equal to 10, y equal to 30. This is my input, right? So I know that add method takes 2 input values. So that's why I'm giving 2 inputs. Okay, 2 input values. Input is x equal to 10, y equal to 30. I know the logic that I have written. I know the logic that I have written. Okay, I know what is that logic. So add method, what it does, when it takes 2 input values, it should add the numbers and then send that result of that number. So that means I know, so based on the logic that I have written, I might be wrong also. Okay. But I'm just, that's why I'm telling expected. It is not actual, expected. See, expectation will not always be true. They might be false also. Okay. Expectation will not always be true. That's why I'm calling it expected. So based on my knowledge I have, based on the knowledge that I have written the logic. I know this add logic is written by me. I know what this logic does. That's why expected output, I say that if I pass 10 and 30, that method should sum those 2 numbers and give it to me. So that's why I know the logic. So that's why the expected output should be 40. But I might be wrong also. Okay. I might be wrong also. Fine. This is expected output. That's why I call it as an expected output. Next, third. Execute the method by passing the given input. How I'll execute the method? How I will execute? In Java, how can I execute a method? I have to first create the object of this class, right? I have to create the object of this class, right? That is compulsory, because this method is an instance method. There is no, it is not a stat. That's why I told for this course, core Java is prerequisite. Okay, core Java is prerequisite. Okay, so you have to call the method. How I'll create from the object of this class. So how I'll do like this: sum s equal to new sum. I call like this. Then I say s dot add of x comma y. What is x and y? Input. This is my input, right? I defined here. Okay, s dot add of x comma y. Fine. Or instead of x comma y, I'll pass here 10 comma 30. Or xy also, because anyhow you have defined x equal 10, y equal 30, right? Fine. Now this method, now this is the actual method you are calling. See, this is your expectation, your assumption, but now you will get the actual output. You will get the actual output. Okay. Now this I am assigning to some int. Okay. Int sum result equal to. I'll say like this: int result equal to. Okay. Now this result. So your actual output. Okay. Okay. This is the 4th step. Okay. This is your 4th step. So your actual output is equal to the result. Your actual output is nothing but the result that is written from this method. Okay. So that's what you see. The 4th step. See, 2nd step is execute the method by, so 3rd step is execute the method by passing the given input. That's what we have done. 4th step is after method execution, after this method got executed, output is written, and this is called the actual output. Yeah, this is returning the output, and this is your actual output. Okay. Now the actual thing lies in 5th point. Okay. The actual testing lies in 5th point. Okay. Now 5th point, what is 5th point? If actual output and expected output are equal. Okay. Now I will compare. If expected output, okay, equals, okay, actual output. This is not the exact Java syntax. I'm trying to make you understand in a plain English way. Actually, that's all. Okay. We'll see the real practical thing in JUnit. How we'll write the unit test case with JUnit Java syntax and all that. Okay. Now this is just to understand you how this is working. If expected output equals actual output, okay, then the test is passed. Else test is failed. So that is what we do here. Now, so definitely, if your actual output here, what will be actual output? What will be your result actually? If this is called, it will call this logic, right? It will call this logic. It will call this logic, because I'm creating an object of this class, s dot add of x comma y. It will call this logic. It will take that 10, it will take y as 30. 10 plus 30 is 40. 40 is written from this method. So your result will be 40. And what is your actual output then? Your actual output is 40. Is 40. Your actual output is 40. Now, what is your expected output? 40. What is your actual output? 40. So expected output equals actual output? Yes. Test is passed. That means my expectation is correct. That means the logic that I have written is correct. Okay. Now, suppose there is a person who don't know even basic maths also. Okay. Let us think like that. Now, there is a requirement that this add method should do addition, but somehow mistakenly, or he don't know basic maths also. I'm just telling, or mistakenly also many people will be doing. Okay. So in place of plus, he will put multiplication. He has written the logic wrongly. And I don't know whether he has written the logic wrongly or not till I execute this unit testing. Okay. He has put a logic like this. Okay. But now our unit testing will tell whether this logic is correct or not. Okay. Now we'll follow the same steps. Okay. Now in this case, test case is passed. Okay. In this scenario, case one. Test case is passed. Okay. Test case is passed. Okay. Case one. Now we'll go to case two. Let us take the same program. Okay, in another scenario. Okay, let us take the same program. Now, somehow by mistakenly, we will say mistakenly, I have written the logic into, but I don't know it is mistakenly also. I don't know, I forget it. I have written the logic and I have left it and I gone to other work, writing other programs, other methods, and I forget about it. But my unit testing will catch this. But my unit testing will point out this. Okay, man, you have written this wrongly. Okay, let us see that also. Okay, first we need to do unit testing of the method. Let us take that. Always follow the first step. What is the first step? Take input to be passed to the method that needs to be tested. Okay. Okay. First, same input will say input x equal to 10, y equal to 30. Okay. My expected output, as usual, I'll think that yes, this is an addition, right? So that's why I'll say that it should return 40, because that is my expected output, right? That is I'm thinking. So this method should return 40 because that is a requirement for addition. Okay. Now let us call the actual output. So now I'll say just sum, s equal to new sum. Okay. Then int result is equal to s dot add of x comma y. Okay. Then I'll say, now your actual output is result, right? Whatever the result, that value. Fine. Result. Okay, fine. Now what is your result? So I pass now 10 in 10 and 30. So that will call this method. So x value will be 10, y value will be 30. Then 10 into 30, how much? 300. Your z will be 300. That is you are returning. So your result will be 300. So your actual output is 300. Your actual output is 300. Okay. Now, fifth point. So if expected output equals actual output, then test is passed. Okay, we'll see now here. What is your expected output? 40. What is your actual output? 300. Is 40 equal to 300? No. That means test is failed. So the person who has written the logic did not notice this. He did not notice it and he has gone to other work. But your unit testing has caught this. Unit testing is caught this. See, this test failed. Then he'll come and see why the test failed. Yes, the expected output is 40 but the actual output is 300. Okay, I have done the mistake in this logic. Instead of multiplication, I should have put plus. Then you'll put that logic and correct that logic. So this is how unit testing will work. So unit testing will catch the issue in your logic. If you're written a method, if you're written a logic in a method, okay, and then if that logic is not, if the logic execution or the method execution result is not matching with your expected output, okay, if your actual output is not matching with the expected output, then the test is failed actually. Okay, so I just told you in a plain English way, but in the real practical things, to implement this unit testing, in Java, we use a library called JUnit. Okay, to implement unit testing in Java, we have a library called JUnit. Okay, JUnit is a unit testing library. Popular, we can say popular unit testing library. For popular unit testing library. Okay, popular unit testing library in Java. Okay. So, see, syntax error is different. Syntax error means you cannot even call this method, right? You cannot call this method. Your compiler will give error. Syntax error is different. Here, the program syntactically is correct. There are no compilation issues. So, program is compiled. If there is an issue in the compilation of the program, then you cannot create the object and call this method. Okay, that is what you have to see. Okay, to implement unit testing in Java, we have a library called JUnit, and we implement unit testing like this. Okay, everyone understood the steps that we follow in unit testing. So these are the steps. See, so these are the steps. Just to read once again. Just to read once again. Okay. So take the input to be passed to the method that needs to be tested. So define the expected output from the method for the given input. Okay. Define the expected output from the method. Execute the method by passing the given input. After method execution, output is written, and this is called the actual output. Okay. So we have taken an example. So first you need to define the input. Then I know that based on the logic that I have written, I can think like expected output is some value, but I might be wrong also. Okay. Then I'll say that, so this is actually, I'm calling the actual method by passing the input, then I'll get the actual output. Then I compare expected output to actual output. Then I say test is passed, otherwise fail. Okay. So to implement this unit testing, we have a library called JUnit. So JUnit is popular unit testing library in Java, and which I'm going to tell you. So I'm going to tell you shortly. Everyone understood the steps? Okay. These are the basic fundamental steps. Okay. So let us now. Let us now start one JUnit program. Let us start one JUnit program, and we'll see how that is working. Okay. So let us start practicals. So for this course, you need to set up JDK 8, Java JDK 1.8. I mean, instead of course, I'll tell you for this tool, JUnit. Because each and every tool, I'll tell you what are the prerequisites. So you need to set up Java JDK 1.8. Next, Eclipse IDE. Okay, Eclipse IDE. Eclipse IDE. So that will have Maven plugin also. Expected output we have to give. We have to give that, right? Expected output is our thinking. I have written the logic. This is I'm expecting the output. Okay, this is I'm expecting the output. Okay. Now you see. So for this tool JUnit, we need to set up Java JDK 1.8 Eclipse IDE Maven plugin. What is Maven? I told you that Maven is again another tool actually, which I'm going to tell you. But for now, I'll tell you a simple way. Okay, Maven, if you have Maven, what Maven does is, Maven will create a default project structure for you. Default Java project structure. We'll give it default Java project structure. Okay. That means Maven will create a default Java project structure. Okay. This is the first step. Similarly, Maven will download third-party libraries required for your project. See, if you don't have Maven, you have to create a project structure on yourself, and you have to download the third-party libraries and put in your class path. All you have to do manually. But Maven is helping you to do all this. What is your default Java project structure? Means I'll tell you. See, for example, Maven will create a project structure for you. How means? So there will be a project here. That is nothing but your folder path. Project. Under this project, so there is a folder called SRC. Okay, under this folder, there is a folder called main. Okay, these are your folders. Okay, so this project can be in your C drive. This is a folder. Under this folder, inside this folder, there is a source folder. Inside source folder, there is a main folder. Okay, under main folder, there will be Java folder. Okay, under main, there will be Java folder. Okay. And under main, there will be one more folder called resources folder. Or resources you have to create manually. Sometimes some Maven versions will be creating like that. So like that will be. So under project, there will be source folder. Under source, so there will be main folder. So under main, so there will be Java folder. Okay, under Java, you will have the Java files. Under Java, all the Java files will be placed here. So Maven will create a project structure. Now under project, there will be a test folder. So there will be a test folder. Okay, under test. So there will be just one. Just 1 minute. I'm getting it. 1 minute. Hello. One minute. Yeah. Sorry, I got one call. Yeah. So here I have to draw this. So SRC main. Here I have to. So SRC. So here you will have test folder. Test folder. Under test, you will have Java folder. Okay. This will be your structure. This will be your structure. Yeah, here you will have packages. Under Java, you will have packages. Packages. Okay, under packages, you will have Java files. Okay. I think we can have like this also. Under Java, you will have packages. You'll have packages. Packages are also folders only. Okay, they will be stored as subfolders in Windows system. Under packages, you will have all the Java files. Java files. Similarly, here also you have the packages. Under packages, you'll have the Java files. You'll have the Java files. So like this, you'll get a project structure. Maven will create a default project structure like this in your. So wherever you're creating your project in C drive or D drive, so that project, these all will be visible as your folders in your Windows system. Okay, you'll give some name to this project. I just put name. You can give some name like a bank app, okay, or customer app. Like this, you can create one project and under this project. Now, so if you take SRC main Java, these are your main Java files. Your main Java files. Okay, which are your which contain your actual business logic. Which contain the business logic. Main Java files which contain the business logic. Okay, under SRC main Java. But there is one more folder you see path under SRC test Java. So here this will contain unit test files. Unit testing files written in JUnit, written using JUnit. Unit testing files under this. So if you see the path like this, SRC main Java contains business logic files. SRC test Java contains test files implemented in JUnit. Contains actual Java files. Okay, that has business logic. We can say like this. Okay. Yes, under SRC main Java. For example, I'll tell you an example. Suppose I have a class. Let us take this class. Let us take this class. Let us take this class only. So this class is saved where? In sum.java. So this is the file name, right? So this sum.java, this is your actual class. This is your actual class which contains the business logic. So this is the actual class which contains the business logic, like your add method. So this sum.java is present in SRC main Java. This is your main class, your business logic. Now we need to write unit testing to some class, and we need to write unit testing to some class. We need to write unit testing to some class and test the add method using JUnit. So this also we need to write unit testing to some class and test the method using JUnit. So this unit testing file also will be saved. That means this unit testing is this one. These are the steps that we write in the unit testing, right? Input, expected output, all these steps we'll be writing in the unit testing file. All these steps we'll be writing in the unit testing file. So unit testing file will also be saved in .java file. Okay, we'll use some name to this, like sumtest.java. I did not write that sumtest.java. I have sum.java, but sumtest.java I have to write passing this like this logic. So this sumtest.java is present in SRC main test folder. SRC test Java folder. SRC test Java folder. Okay, so here you will have sumtest.java, and here you will have sum.java. So that means all the unit testing files which are written in JUnit will be stored in this project path, in this folder path, and all your business actual Java files which contain the business logic for your application, all this will be stored in this path. So all this will be stored in this path. Okay, sum.java is present here, and then sumtest.java is present in this. Okay, take this diagram. So take this diagram. So this is your Maven project structure. Okay, Maven default project structure, or default project structure created by Maven. So default project structure created by Maven. Okay, so you can take this diagram. Actual logic. Okay, fine, right? So your sum.java is present in the SRC main Java, which contains your business logic, and the unit testing code which you are going to test this add method, which you are writing in JUnit, will be present in some test.java, and that will be present in this folder path, src test Java. Okay, so everyone understood this folder structure? Everyone clear about this folder structure? Everyone clear about this folder structure? Right? Right. Now, so what is the benefit of Maven? Maven will create a default Java project structure like this. Okay, like this. Okay, like this, it will create a default project structure. Okay, so under project, src folder, under src folder, main folder, under main folder, Java folder, under Java folder, all your business files will be there, or your actual main files. Under test, all your files will be there. But remember one thing, Maven will create only till this part, only the folder structure and one simple file, like a hello world program. But these are the files that are written by you, your sum.java, your sumtest.java. So these files will be written by you. So you have to copy that files in this correct folder structure. Suppose Maven will create a folder path like this for you. So then whatever you have written sum.java, you have to copy that in this path. Whatever you have written sumtest.java, you have to copy that in this path. You have to copy manually. If you have an Eclipse ID, you can easily add. I'll show you that how we can do that. Okay. So Maven will create a folder path like this, and whatever the files that you write, whatever the business main files you write, you have to place under src main Java, and what are the packages? Packages are nothing but subfolders, right? You have to place that file under this path. And what are the unit test files that you write using JUnit, which I'm going to tell you. That is the purpose of this course, purpose of this tool actually, which I'm going to tell you. What are the unit test files that you write using JUnit? So those have to be put under test source src test Java. Under this folder path you have to put it. So that's what. So all your business logics will be placed under here. All your test files you have to write. See, Maven is not going to create your files. It is going to create only the project structure. So the files that you write have to be put in the appropriate paths. Okay. So that is the important thing of Maven. But we'll study the detailed Maven when we study the tool. Okay. So Maven will create a default Java project structure. That is the first one. And Maven will download third-party libraries required for your project. What do you mean by this is, say now, in my project, I am using JUnit library for implementing unit test case, for implementing unit testing. And this is a third-party library. JUnit is a third-party library. Okay. Now, if I don't have Maven, what I have to do? I have to download this library, and then I have to set in my project. But Maven, if you have Maven will automatically download this. Okay, I'll tell you how. Okay, if we don't have Maven, Maven will automatically download the required library. Sorry, if you have Maven, Maven will automatically download the library. Where it will download also, I'll tell you from where it will download, and add this library in your project class path. Okay. What is project class path? Project class path means any library that is in the project class path will be recognized. Okay. I'll tell you, very simple. Suppose I have a package. Okay, I'm importing a package like this. Import some XYZ. Okay, I'm importing this package. Okay, simple. Okay. And I'm writing a class A, and I'm using some class from this XYZ. Okay, something like X, or let me take a real example. I'm importing a package like org Apache dot, okay, some library, HTTP dot something. I mean, I'm writing a package, I'm importing a package. Now from this package, there are some predefined classes where I'm using, okay, like HTTP servlet, something like this. I'm using the class, and this class is part of this package. Okay, and this class, okay, or we can say like this, Java X dot servlet, or we can say like this, instead of import org, or I'll just say like this, some MySQL, I'll say MySQL stuff, because HTTP servlet is part of Java X. So MySQL, I'll be just doing like this. And then here I'll just say some, I'll use some library. Okay, don't worry about Mammon. Mammon you will study in detail. Now I'm just giving a brief idea. Okay, brief idea. Suppose I have a library like this, MySQL.start, something libraries. And from this library, I'm using some class, like something like MySQL connection. Okay, something like this. I'm using something like this. Okay. See, I'm just telling in a rough way. Okay, it is not actual, because if I go in a deep way, when I explain you Mammon, I'll be telling you all this. Now I'm just telling MySQL connection and something. I'm using the class from this library. I'm using some class from this library. So this library should be available in your class path. Otherwise, here you will get a compilation error. What is this class? What is this class? Your compiler cannot recognize what is this class. So this class is part of this library, and this library is present in some jar. So that jar should be added in your class path. Okay. If the jar is added in the class path only, this class is recognized and this import is recognized. Otherwise you'll get compilation issue. Okay. So if you don't have Maven, you have to download this and you have to add that in class path like that. If you have 20 libraries to be downloaded, you have to download all those 20 libraries and add in the class path, which is a difficult effort. Instead of that, if you have Maven will automatically download the required library, and add this library in your project class path. So Maven is doing two benefits mainly, but there are so many benefits which I'm going to tell you when I tell you Maven, because Maven is the third tool which I'm going to explain. Okay. Now, so Maven will create a default Java project structure like this. Okay. And the second one is it will download the required third-party libraries required for project and add in the class path. If the library is not in the class path, it will not recognize, Java cannot recognize that library. Okay. So now in my project, I'm using JUnit library for implementing unit testing. So now I will take help from Maven to download JUnit library and add to my project class path. So this is what I'm going to do. Okay, that is why I brought Maven concept here. You might think that Maven is a third tool, then why Maven has been explained here? Because JUnit is one unit testing library, which is a third-party library. To download that library and add to my project class path, I'll take help of Maven instead of I do manually and do it. And how I will do using Maven, I'll be showing you. So first step is we'll create a default Java project structure. Okay, under the default project structure, whatever the test files are there, that will be placed in this folder path, and whatever your main files are there, that will be placed in this folder path. Any questions till now? Any questions? Everyone is clear, right? Whatever today I have told you. Yeah, Google Classroom link I'll get you by Monday. Okay, tomorrow, day after tomorrow, there are no classes. Okay, Okay, tomorrow, day after tomorrow, there are no classes. So Monday we'll meet actually. Monday I'll tell you how to install Eclipse, how to set up Maven, and how with the help of Maven, how we can create the project structure like this. And with the help of Maven, how I can download JUnit library, I'll tell you. Okay. So with the help of Maven, how we can create this project structure. Okay. How we can create this project structure. And then with the help of Maven, how I can add, how I can download the JUnit library. Okay. Thank you. So everyone understood clearly? Yes, I see good messages. Very good. Why we need to keep unit testing files in the project? So that's what, right? Unit testing files are very important to test your method is working fine or not. Okay. If unit testing files are not put in your project, okay, that method cannot be tested. Okay. See, for example, that's what I told you. For example, you have written this logic. Okay, mistakenly you have put multiplication in place of addition, and you are doing the other work. You forget about that. Okay, but someday your unit testing will catch this issue. Whenever you execute the code, your unit testing will catch this issue. Whenever you execute this project, your unit testing will catch this issue. That is the reason unit testing file should be part of your project. If you put outside the project, your unit testing files cannot test your class or method. So that's why unit testing files should be put inside the project. Okay. So tomorrow is a holiday. Sorry, tomorrow there is no session. I mean, not sure about holiday, but tomorrow, day after tomorrow, I am not going to take the session. Monday we will meet actually. Okay, Monday. Okay, I'll take the Google Classroom link. I'll take the Google Classroom link and I will upload these notes in the Google Classroom link. So JDK 18 installed, not an issue, but you can, yeah, not an issue. JDK 18 installed is not an issue. That is the latest version. Not an issue. Eclipse ID is also for E fine. Okay, all right then. So tomorrow there is no class. Okay, tomorrow there is no class. We'll meet on Monday. Okay then. Thank you all. See you on Monday. Okay, I'll tell you websites and everything. Okay, next week I'll tell you. Okay, first you can take the notes and listen to my class. Then I can tell you that what are the further things that you can go and everything. Okay, tomorrow there is no session. So we'll meet on Monday. Okay, I'll upload you I'll take the Google Classroom link and I will upload the notes. Okay, thank you all. See you on Monday. Okay, thank you all. Thank you.